Hello, Algebra 2 and or perhaps pre-calc or trig scholars. We are in the middle of a unit on logarithms, and we've been working on simplifying logarithmic expressions, the ones where you expand or write as a single log or evaluate, basically. And one of the things I wanted to spend a little bit more time on is estimating logs. So, actually, I'm going to walk across the room for a second and grab a sheet that we started working on at the end of the class. So let's look at this. These are logarithmic expressions that cannot be simplified directly, and the direction was not to use the change of base formula or anything in the calculator, but just to basically solve this by estimating. Notice it's multiple choice. If I asked you to do this and I did not give you multiple choices, the best you could do is come up with a close answer, but you couldn't really say too much for sure. You couldn't be quite as precise, let's put it that way. There's a lot you can say here though. Let's talk about how we could do this. Log base 2 of 9. Anytime you have log base 2 or log base any base of, and this is your argument, you look at the argument and you ask yourself whether it can possibly be rewritten in terms of a power of this number. In other words, rewriting my argument, which is 9, as a power of 2. Well, clearly with 9, that can't be done. I cannot write 2 to the something in place of 9. However, I do know that 2 to the third is 8. Right? 2 to the third is 8, which is really close to 9. And this would simplify as just 3. So I can expect that if I take this number and make it just a little bit bigger than 8, then I'm going to get an answer that's just a little bit bigger than 3. If you think about it, another way of looking at it is log base 2 of 2 to the 3 gives me 3. Log base 2 of 2 to the 4th gives me 4. This is 8. This is 16. So if I'm going to do this with any number here, if my argument's going to be any number between 8 and 16, then I'm going to get an answer that's between 3 and 4. And in my multiple choice problems, there's only one that is, and it's C. Okay, let's look at the next one. Next one says log base 3 of 1.5. Okay, so let's think about log base 3. Well, if I had log base 3 of 3 to the 0, that would be 0. What is 3 to the 0? 3 to the 0 is 1. Remember, log base whatever of 1 is always 0 for that reason, because it doesn't matter what your base is here. That base to the 0 will give me 1. Okay, so log base 3 of 3 to the 0 gives me 0. Log base 3 of 3 to the first would give me 1. 3 to the first is 3. So if I had a 1 here, where the 1.5 is, my answer would be 0. If I had a 3 here, where the 1.5 is, my answer would be 1. So I'm looking for a number between 0 and 1 because my argument is between 1 and 3. So 0 and 1 between there is B. Okay? Look at the next one here. Actually, look at the next two. If you'd like, you can pause the video and try them yourself before I go over them. Log base 2 of 16. Can 16 be written as a power of 2? It can. 16 is 2 to the 4th. So this whole thing is just going to be 4. Plus log base 2 of 21. Can 21 be written as a power of 2? It cannot. So let's think about what it's close to. Well, we just said that 2 to the 4th was 16. Okay? 2 to the 5th is 32. 21 is between 16 and 32. So it's going to be 2 to the something between 4 and 5. So I'm just going to say 4 point something, whatever. So when I add these, I know it's 4 plus 4 point something, so it's going to be 8 point something. And there it is. Next. Log base 5 over log base 4 of 5 over log base 4 of 2. Okay. Log base 4 of 5. Well, log base 4 of 4 would just be 1. If I'm going up to 5, then I'm going to be adding just a little bit more to this. 1 point something, maybe 1.1, 1.2, right in there. So we're going to estimate that as about 1.1. Something in that ballpark. Log base 4 of 2. Can 2 be written as a power of 4? Yes, it can. Okay, and when we do this, what we're thinking is, and this is a way you can actually write it out if you need to. We're saying, what can I rewrite 2 as that is a power of 4? So what we're really saying is 2 equals 4 to what power? Okay? If 2 squared equals 4, then 4 to the 1/2 equals 2, the reciprocal of that. 4 to the 1/2 is the same idea as square root. So 4 to the 1/2, or the square root of 4, is 2. So this is log base 4 of 4 to the 1/2 power. So that whole denominator becomes 1/2. Okay, if we divide by 1/2, dividing by 1/2 is the same as multiplying times what? Dividing by a fraction, you flip it and multiply. So we've got like 1 point something, let's just do this, divided by 1/2. That means 1 point something divided by 1/2, which means 1 point something, times 2 over 1. So 2 times 1 point something is going to give me 2 point something. Okay, now we have two 2 point somethings here. So let's get a little bit more specific. We said that it should be just a little bit bigger than that, because log base 4 of 4 to the 1st is 4. Log base 4 of 4 squared, let me just make this a little less cluttered. 4 to the 1st, that's going to be 1. Log base 4 of 4 to the 2nd is 2. 4 to the 1st is 4. 4 to the 2nd is 16. 5 is a whole lot closer to this. 5 is right here, if we think about it almost like on a number line. So 5 is going to be much closer, 4 to the 5th, excuse me, 5 instead of 4 to the 1st. This is going to be much closer to 1 than it is to 2. In other words, it's log base 4 of 4 to the 1 plus a little bit, like 1.1, maybe as big as 1.2, but no bigger than that. Probably in the 1.1 range. So if I do 1.1 times 2, I get 2.2. So to me, this is a much more reasonable answer. And that's the one I'm going with. So let's try some more of these. And you're welcome to check on the calculator what it actually is. But here, I'm going to give you a sheet, show you a sheet with 8 problems on it. If you'd like to, pause now, try as many as you'd like, and come back and watch me solve them. So go ahead and pause now. Or now. You paused? Okay. So here I'm thinking about log base 7 of 7 squared, which is 49. Okay, that's a little bit less than that. Okay, so this is going to be a little bit bigger than the answer I would have for 49, which is 2. So it's going to be 2 plus a little bit. I'm going to write it like that. 2 plus a little bit. Maybe 2.2, maybe 2.3, probably not quite that big. Because if we have log base 7 of 7 squared, that's 49. Log base 7 of 7, the next one up, to the 3rd power, 7 to the 3rd power is 343. 50 is so much more close to 49 than it is to 343. So it might not even be as big as 2.01, I mean 2.1. It may be 2.07, 2.08, something like that, 2.06. It's going to be a little bit bigger than 2. Okay? So we're assuming we would have multiple choice. so that we have something. I can't give this as my answer. We're just talking about how would I know where to estimate it. Okay? Here we go. Log base 3. Let's look at log base 3's. Log base 3 of 1. That's 3 to the 0. So that whole thing would be 0. Log base 3 of 3. That's 3 to the first. So this whole thing would be 1. Log base 3 of 9. That's 3 to the second. So this would equal 2. 5 falls between 3 and 9. Closer to 3 than to 9. Not necessarily super close to 3. I mean, it's 2 away from 3 and 4 away from 9. So I'd say maybe 1.3, 1.4, somewhere, if this was a number line, somewhere in here. So let's just guess somewhere like 1.35, 1.4, somewhere in there. 1.2 could be. All right, just talking ballpark here. This one, what's my base? I don't see a base. What do I do? Uh-oh, here comes a custodian. It's going to get loud. This is 10. Common log. If you don't see a base, it's log base 10, and we call that the common log. And it is in the calculator, so you could do that if you're using a calculator, but again, we're assuming you're not. Okay? So I'm going to compare this to log base 10 of 100, which is log base 10 of 10 squared. So that would be 2. So this is a little bit smaller than that. So I'm thinking, I don't know, maybe 1.7, 1.8, somewhere in there. It's smaller than 2. It's smaller than 100. So my answer is going to be smaller than 2. But it's bigger than 10, which would give me an answer of 1. It's a lot bigger than 10. So it's somewhere between 1 and 2, probably closer to 2. Log base 6 of 40. What power of 6 is 40 close to? Well, thinking of the powers of 6, 6 squared is 36. 6 cubed is, I think, 216. Yeah. Okay. So 40 is much closer to this one. So my answer, we're basically saying this is log base 6 of 6 to what power? And we're going to say this is like 2 point something. 2 plus. So 2.06, 2.09, 2.15, something small. Let's go with 2.1. Okay, number 5. Log base 2 of 16. Can 16 be written as a power of 2? It sure can. So this one's going to come out exactly, and that's 4. Did we just do this one? We may have. I think we did. Okay, plus, we'll just finish it off. 21 is a little bit bigger than 16, so this is going to be like log base 2 of 2 to the 4 plus a little. It's not 2 to the 5th, because 2 to the 5th is 32. So this is 2 to the 4th is 16, 2 to the 5th is 32, maybe 4.4, 4.3, something like that. So my answer is going to be about, I want to know, 8.3, 8.4, somewhere in there. Log base 5 of 20. 5 squared is 25. So my answer is going to be less than 2. 5 to the first power is just 5. So let's go with 1.7. Okay, this one I need to think about because 25 can be written as a power of 5, but then we've got an exponent on it too. So I'm going to have to think about how can I take this, right, 25 squared as a power of just the 5. So, excuse me, give myself a little bit more space here. I'm going to rewrite 25 as 5 squared. So I rewrote just what was inside the parentheses there, but that still has a 2 outside. And when we have a number inside, an exponent inside parentheses and one outside, we multiply them. So this is 5 to the 4th. So my answer here is 4. So this would be, 2.3-ish in the negative direction, something like that. This one we just did, so I'm going to skip it. You can see earlier in the video if you wish to. But I did want to talk about this one. Again, whenever we do these, we're saying, whenever we're trying to simplify a log, we're saying, is there any way that what's right here can be written as 3 to something? So when I see this, I'm asking myself, how can I write that as 3 to a power? So I'm going to take this 9, and I'm going to rewrite it as 3 squared. So I'm just writing the 9 now. And then I've still got that 3/2 outside. When I multiply these, 2 times 3/2 is 2 over 1 times 3 over 2. And my answer is 3. So this is 3 cubed. So all of this whole thing becomes 3. This is log base 3 of 3 cubed. Okay, so that gives me 3 on top. Log base 5 of 115. Well, 5 squared is 25. 5 cubed is 125. Looks a lot closer to this to me. So let's say 2.8, 2.9, something like that. Now, it doesn't matter whether it's 2.8 or 2.9 or 2.7. The denominator here is smaller than my numerator. It's close, but it's smaller. Okay? When the denominator is smaller than the numerator, your whole fraction turns into a number larger than 1. If the numerator is smaller than the denominator, it would be a number smaller than 1. But here, I know this is all going to turn into a number larger than 1 together, because the numerator is greater than the denominator. And so I would just leave it like that for right now. And again, you're not going to give any, none of these are perfect answers. None of these are answers I would give on a test and be happy saying, yes, I'm exactly right. We're just talking about, let's think about how to estimate this. If you have multiple choices, then you can narrow it down now. Ta-da! That's it. See you later.